Okay, great. Before we talk about what we're going to talk about today, I want to take you back to about 7th or 8th grade, and I want to ask you, what type of a function is that? What type is it? Is it quadratic? No, it's linear. Good, okay. So we see a linear function there. So does this linear function 3x plus 2 have a domain? What would it be? Good, all real numbers. Does it have a range? Yeah, what would it be? All real numbers. Yes, very good. Does this function pass the vertical line test? Yes, it does. How do you know? Because it's a line. Good. So if it passes the vertical line test, that means it's guaranteed to be a function. Does it pass the horizontal line test? Yes, it does, because after all, this is a line. So that implies that it has a what? No. Inverse. Bailey, very good. Ladies and gentlemen, your task right now is to find 2 over 3. Okay? Who agrees that the inverse is x minus 2 over 3? Hands up. Okay, most of us here. Good. I'm wondering, what are the steps you wrote down to get that? What'd you do? What's the first thing you did? So, okay. Change f of x equal to y. Good. Step number 2. Then what'd you do? So switch x and y. Okay. Switch x and y. And then the third thing, what'd you do? You guys solve for y, right? Okay. Yeah, exactly, right? And then finally make y equal f inverse of x, right? Okay, good. Okay, so here's my step 1, step 2, step 3, and we got an inverse function, right? No problem. Okay, good. Now let's apply this here. I'm going to give you a new function. F of x equals 3 to the x. Now instead of a linear function, this is what type of function? What's the thingy? What's thingy? No, this is an exponential function, right? This one was linear. Okay, and we got the inverse for it. This is exponential, right? Okay, ladies and gentlemen, I'd like you to do the same process. Okay, ladies and gentlemen, help me out here. So I'm betting. I was walking around the room, and here's what I saw. I saw people doing like this. People going, okay, y equals 3 to the x, right? And then I saw people doing like this. X equals 3 to the y. And then, so that means you've accomplished step number 1. You've accomplished step number 2, interchanging x and y. But step number 3, we get hung up. That's a toughie, right? Okay, now, here's the deal. Check it out. X equals 3 to the y. There's only 2 variables on the paper. We should be able to solve for y. So what do you get when you solve this for y? It's up in the heavens. Okay, ladies and gentlemen, here we go. Here is our definition for us, okay? This is part of the definition. A logarithm is an inverse to an exponential function, all right? It will allow us to solve this little equation up here that we got so stuck on and so upset with. It will allow us to continue our study of inverse functions, and it will allow us to graph inverse functions of exponentials. So when I see you walking around the hallways, I'm going to say, hey, what's a logarithm? You're going to say, a logarithm is an inverse to an exponential function. It's b of x. Okay, this is the second part of the definition. First, we realize that a logarithm is the inverse to an exponential function. Then we're allowed to say, if x is equal to b to the y, then y is equal to log base b of x. So let me break this down for you a little bit more, okay? The b stands for the base, okay? And notice that the b on the left-hand side is the same b that's over here in the subscript of the logarithm, okay? The y is the exponent. So notice that the y is solved by itself over on the right-hand side. So essentially, a logarithm is nothing more than an exponent as well, okay? And then notice that you still have your x value here, and it's the same x value over there. So I'm color-coding these things to show you that they are the same. And the first thing that we're going to learn how to do is switch between these two forms, okay? So this form over here, we call this exponential form. Which makes a whole lot of sense because there's an exponent in it. Right? This over here is what we call log form. Which makes a whole lot of sense because there's a log in it. Okay? Now, okay, part A, we have an exponential equation. We have exponential form. And do you guys agree that 3 squared is equal to 9? Yeah, I agree too, right? Which number is the base in 3 squared equals 9? 3. Yes, 3 is the base. Okay, that's good to know. Which number is the exponent? 2. The 2 is the exponent, right? 9 is the answer. So if I change this to log form, I start with the exponent. 2 is equal to log base 3 of 9. Okay? So I've changed it from exponential to log form. Here is how you check it. You start with a base. 3 to the 2 equals 9, or gives me, this is what I say in my head, okay? 3 to the 2 gives me 9. The circle of life, right? So if you want to go back up here and write that down, say the base to the y gives me back x, okay? So base to the gives me. You guys cool with that part? Okay, so let's try another one here, and I'll set you guys free on your own. 5 to the negative 1 equals 1/5. This is an exponential equation, exponential form. So I'm going to start with the exponent, okay? Negative 1 equals log base 5 of 1/5. And then I'm going to check to make sure that I'm right. Start with the base. 5 to the negative 1, does that equal 1/5? 5 to the gives me. And of course, right, and remember, anything a to the negative n power is equal to 1 over a to the n, right? So example, 5 to the negative 1 is the same thing as 1/5. That's all true. So log form, 1 equals log base 5 of 1/5. You guys on board so far? Okay, good. So I'm going to give you a few more I want you to try on your own. Here is part C. Okay, please do 13 squared equals x. Here's part D. Please do b to the third equals. All right, let's go the other way now. Let's go practice going the other way. We're going to have log base a of 4 equals 5. So how do I change from a log form to exponential form? Well, again, we're going to start with the base. So a to the 5th equals 4. So write down a to the 5th equals 4. Right? And then you're all done. Yeah, very good. Yeah? Okay, part B, try this one. What do I give you? Log base a of b is equal to negative 3. Okay, we start with the base. So a to the power of negative 3 gives me b. A to the negative third gives me b. What do you think so far? You got it? Okay, here's C. Do log base b equals 64. You guys are totally on board with that, okay? Good. Easy? So how many of you feel good about going from logarithmic to exponential and vice versa, exponential back to logarithmic? Good? Okay, good. Now here's what you do. Go back up to box number 1, and I would like you to 3 of x. Okay. You guys ready to move on? All right, good. Here we go. The next idea I have for you, the 5th box here, is what I call the most amazing, fact ever. It's an if-then statement. And the reason I call this the most amazing fact ever is because in every single year, somebody always figures it out, right? Because it's kind of one of those things that's like, well, why is this even like true? So here's what I mean. If b to the x is equal to b to the y, if you know that b to the x equals b to the y, what has to be true? X equals y. That's it. See, it happens every single year. Somebody figures it out. That's why I call it the most amazing fact ever. because it's almost like we already have this information somewhere buried in our brains, but we never actually think about it. So I'm telling you, if b to the x equals b to the y, then x has to equal y. It can't be any other way. So how do we use this information to help ourselves out? Well, here's what we do, right? Let's say, as an example, I want to find exact values. Now, when I say exact, what do I mean? Log base 2 of 16. All right, ladies and gentlemen, log base 2 of 16. This is an expression. I want the exact value for the log base 2 of 16. Now, this looks weird to you, but this is just a number that we all know and love. How do we come about understanding what this number actually is? How could we start? Yes, the answer is 4, but how do we get that? Very good, Holland, very good. So we're going to say, okay, well, we know that this is a log form, so let's change it to exponential. Let's say, okay, 2 to, I'm not sure what it is, but it has to be 16. 2 to some number has to be a 16. I'm not sure what it is. Okay, now, I know that if I could get my bases to be the same, then I'm guaranteed that the exponents have to be the same, right? So is there a way I could change a 16 into a base of 2? Yeah, so couldn't I just say that 2 to the x is the same thing as 2 to the 4th? Because 16 is just 2 to the 4th, right? And if my bases are the same, then, oh my gosh, x has to be 4, so this is a fancy way of saying of 1/3. Ready, set, go. In your groups, log base 3 of a third. Find the exact value of... All right, so it looks like a lot of people got -1 out of there. Cindy, can you explain how you got -1? Yeah, so she changed 1/3 into 3 to the -1 because that's the same thing as 1/3 is the same thing as 3 to the -1. And then your bases are the same, so therefore x has to be -1. So therefore all of this has to be a -1. Good.
So you know that, okay, this is where, like, yes and I were just trying to figure out how we got one.
Okay. 25
you know
to...
that 25 raised to something has to equal 5.
Yep.
And you know that it will be, because 5's smaller than 25, it's going to be a fraction.
Okay.
So you know that, like, last year we learned the little thing where it's like, if it's raised to a fraction, you take the, well, I don't know what
Okay.
it's called,
Yep.
and swing it around, so it's like the square root. So
Yep.
you know the square root of 25 is 5, so you want to find the square root of 25, so it's 1/2. Then it would
So yeah, it's true that 25 to the 1/2 is the same thing as 5, okay? So here's another way you can do this. The other way I did it is this. I rewrote the number 25 as 5 squared. Is that true? And I still have to the exponent of x, and that equals 5. So all I did was I changed 25 to a base of 5 squared because I want the bases to be the same. So since 5 squared, what do I do when you raise a power to a power? You multiply. So this is 5 to the 2x equals 5 to the first power, right? So if my bases are the same, then my exponents must be equal. So 2x must be 1, so x must be 1/2, which is the exact same thing that they got by recognizing that 25 to the 1/2 is the same thing as 5. Equals 2 to the 1/5, yep. So then x must be equal to 1/5. Yes, you're absolutely right. Very good. Okay, part E. Who got E? You want to try it? Okay, Griffin, did you get E?
Yeah.
What'd you get?
-2.
Yeah, how'd you get that? I kind of just knew, yeah. So 7 to the something is 1/49th. So 7, for me, this is my process, my thought process, right? I go, that's 1/7 squared, right? Right? Okay. So 7 to the x equals, well, that's just the same thing as 7 to the -2, so there's your answer. X equals -2.